The whole thing, please. Cross. Every point along this line has a value, yes? The line that I have labeled. What values do those have? They're an X value, aren't they? If I put my pen anywhere along that line, what do you know about that spot? It's an X value. Is it a point on this graph? Or on this coordinate plane? Yes. So you know that because it's a point on the plane, it must have an X and a Y value, correct? You do not know the X value there, but do you know the Y value? 0. This point is X, positive or negative X? Positive. This point is X comma 0, isn't it? Okay. What is this point? X comma 0. What is this point? Negative X comma 0. What is this point? Negative X comma 0. If it happens once in math, how often does it happen? Infinitely. So, if you have a point anywhere on the x-axis, what is its value automatically? X comma 0. Every one of those, right? Okay, you're intelligent young people. What is that point then? 0 comma y. What is that point then? 0 comma y. What is that point then? 0 comma negative y. And what is that point? So now what do you know about every single point that is on the y-axis? They are all going to be what? Zero comma y, right? Everybody with me? Okay. What happens if I connect these lines? What have I just made in all of these spots? And all of these spots? Intercepts. All right? Which color are the x-intercepts? Green. Which color are the y-intercepts? Yellow. Does everybody see this? Please notice that in 4 different examples, the x-intercept is always some value of x, comma 0, right? When we leave in math a letter instead of a number, why are we doing that? Because we don't know the number. You cannot tell me what that x is because there's no scale on this graph, is there? I could tell you that x was 3,727,279, couldn't I? Or I could tell you it was 2. Does everybody understand that? Okay, so x-intercepts are where a graphed line crosses the x-axis. And they are always x comma 0. Everybody understand? The y-intercept then is the same thing, except it's where a graphed line crosses the y-axis. And they are always zero comma y. Always and always. Does everybody understand this concept? Yeah? Okay. Now, if you really understand this concept, you should be able to fill this in. For the red line, what is the x-intercept that would be on this table of values? For the red line, I want the x-intercept. What would I write in the table of values? X. I want the x-intercept. I've highlighted on this page what every single x-intercept is. There's no commas anymore. I'm on the table of values. What number am I writing there? 0. What do I write for the y-intercept? 0, y. Does everyone understand this? I'm going with dead silences being yes. Which means, of course, when I ask you to apply this knowledge in 5 seconds, all of you are going to be able to do that, right? Because none of you have said that you do not understand this. Does everyone get it? Okay, now, if I have a table of values, what can I do with the table of values and an equation? You've done this a million times in Math 9 and 10. If you have a table of values, what can you do with those values and an equation? Fill it in, right? So, let's do that. Determine the x and the y-intercepts for this equation. F of x equals 2x plus 3, which means I need a table of values. Since I only care about the intercepts, what are the only values I need to put in here? 0. And what for y? If x is 0, what's the y value going to be? Y. And x and 0. We're going to do this line first because this is the x-intercept. X is still x. So what do I do with the equation? X is 0, or x is x, y is 0. Where do those numbers go over here? This is exactly what you ended Unit 5 with. If we wrote the test today, every single one of you should be able to do this. Because I have video evidence of all of you agreeing that you understand function notation. So where does the x go? Where does the 0 go? Over here. Talk to your neighbor if you cannot remember this. It was 24 hours ago. That's tough. Would anybody like to tell me what to do right now? Let me give you a hint. In function notation, doesn't y become something else? What does y become? F of x. Maybe that will help. X is x. F of x is 0. What do I do now? I put the 0 where, Aiden? You replace f of x with 0 equals 2, what's x? Still x, plus 3. Do you have an unknown here? What is the unknown? X. How do I solve for it? What do I have to do to get a value for x? Minus 3 minus 3. Negative 3 equals 2x. Now what? Divide by 2. X equals negative 3 halves. If x equals negative 3 halves, and I have an x here, what can I write here now? Negative 3 halves, or negative 1.5. Is everybody cool? Does that now give me an x and a y value? This is a yes or a no question. Yes, I could write it as negative 1.5. If I have an x and a y value, can I put it on the graph now? Yes. The question now becomes, and I haven't taught you this, should I put it on the graph now? Avery and Ryan are both shaking their head no. They know it's a 50-50 shot. Why would I not want to put this on the graph right now? Because there's a fraction. I don't know. What if that y is a fraction? Then I got to change these, don't I? If I make each of them 1, it's a pain, right? So let's check the yellow one. What do I do with that one when I have f of x equals 2x plus 3? What do I know here? Fx is still fx, or we could call it y, because they're the same thing. Y equals 2 times what? 0 plus 3. What is it? Y equals 3. If y equals 3 in algebra, what does y equal on my table? 3. Do I now have an x and a y value for that? Yes. I do, don't I? Okay. Now, one of them is a fraction. One of them is a whole number. So now you have to actually understand what is happening in math. If I make every one of these 1, then this negative 3 halves dot has to be in the middle, doesn't it? That's a pain, isn't it? So what would happen if I told you that on the x-axis, 2 squares equals 1? Does that make it easy to find a half? Sure it does. Where is negative 3 halves 0? If each of these squares is worth a half, where do I have to go? 3 squares over. Which direction, Michael? Why left? Because it's negative. 1, 2, 3. Everyone agree? And that point is negative 3 halves 0, isn't it? Now, if I keep that same scale, then where do I have to go for my y of 3? I would have to go up 6, wouldn't I? Does that fit on the graph? Sure it does. So we can do that, can't we, Evan? What if this was 18? Could I go up 36 squares? No, because the graph ends. So what would I have to do? The same thing I did here. Change the scale. Does everyone understand? You're allowed to change the scale as long as you label it to show me you have changed the scale. Does everybody get that? Now, since 6 fits on the graph, 6 squares, we can use the same scale. Up 1, 2. So 1, 2, 3. There's 3. Agreed? Now, is this a linear relation? Yes or no? It is. Why? What's the hint that lets you know it's going to make a straight line? No exponents. So since I know it's going to make a straight line, and I know I need 3 dots, right? If it's going to make a straight line, if I go down 6 and left 3, then could I not go down 1, 2, 3, 4, 5, 6, and left 1, 2, 3, and get my 3rd dot? And there's my line. Yeah, you could, but remember we need 3 to prove it's a straight line, right? Because if I put the 3rd dot over here, that's not a linear relation, is it? Is everybody good? Now, quick review of last unit. What's the domain and range of every straight line? As long as it's diagonal. What's the domain? How far to the right is this line going to go? Infinite. How far to the left? So the domain is x is a set of real numbers, isn't it? What's the range? Y. How far up is that line going to go? How far down? So y is a set of real numbers. Does everybody understand it? Find the intercepts with the 2 values. Check how far they are apart. Make a 3rd line or a 3rd point and connect them. Is there anybody that feels they cannot do this? At least get started. Everyone is good? Now listen to me. If you understand this concept of putting these numbers into this equation, that's this entire unit. Do you understand that? That this x value goes anywhere I see an x. Does everyone get that? Stop me now if you don't. Okay, turn the page over. Uh-oh, Mr. Myers, you're so mean to us. Fractions again. Why you gotta be that way? Why has the function got a new name? It's g of x. It's just to remind you that you can name them differently. So, since every single one of you told me you understood this, every single one of you should be able to do this. I'll help you get started. Equals 1/2 x minus 2. Since I'm using intercepts, what are the values that I will be subbing in here? The first value I use will be what? You have a choice. Doesn't matter which one you do first. So Ayaka has said we're going to use x and 0 first. And then what's the other value we're going to use? 0 and y. Everybody good? Go. Does everybody have their 2 points? Evan, what is one of your 2 points? Because you've been nodding the whole way. I'm thinking you're getting it. I'm thinking that you're getting it because you've been going the whole time. So give it a shot. Great. What do you have for x? You have x of 0. So you put x. Oh, you can't see this yet. So when x is 0, you put 0 for x. 1/2 of 0 is what? 0. What's 0 minus 2? -2. So when x is 0, y is -2. In the other one, you knew the y value was 0. So you put 0 for y, x was x, added 2 to both sides. 2 equaled 1/2 x. How do you get rid of divided by 2? Multiply by 2. 2 times 2 equaled x. So 4, 0. Does everybody understand? Maybe you didn't do it that fast. Do you see what we did? Now, because those are all, there's no fractions there, do I need to worry about doing a weird scale over here? No. I can put the first dot in at 1, 2, 3, 4, 0. Put the second dot in at 0, -2. Check. I got to go up 2 and over 4, right? So the next point is either up 2 and over 4 or down 2 and over 4. Now I've made 4 dots and I can connect my line. What is the domain and range? Because it's a straight line? All real numbers. Can everybody do this? You must stop me now if you can't. Are you all okay? Which part, William?
How you started off first, like what's the first step?
Okay. I'll erase all the mess. Are you okay to there? That's the formula, the equation we're using. And we know our x-intercepts are x0 and 0y. Do you get that far?
Yeah.
You understand that you understand this, right? Okay. So now, x is x, right? What letter is that? X. So I have 1/2 x minus 2 equals, no. Y is 0 right now. G of x is y. So this becomes 0. So 1/2 x minus 2 equals 0. Cool? Then I just solve it. This is just algebra. Right? I add 2 to both sides. 1/2 x equals 2. How do I get rid of divide by 2? I multiply by 2. They cancel. 1x, x equals 2 times 2 is 4. Are you cool to there? Okay, so you need algebra help. That is something you have to come and help get. Okay, I can't reteach you 8 years of algebra. All right? But once you get to here, when you get good with algebra, you understand x equals 4. There's an x. So I put a 4 there. And now I have 4, 0. That point right there. 4, 0. Cool? Then I would do the same thing on the other side. X is now 0. So I have 1/2 of 0 minus 2 equals y. What's half of 0? 0. What's 0 take away 2? -2. So -2 equals y. There's a y, so I can write -2. Okay? So it's algebra letting you down, not this. You gotta learn algebra somehow. If you don't want to learn it from me, you gotta go and learn it. Because no matter what math you do next year, you need to be good at algebra. Okay? All right, everybody good? All right. My second favorite font, Cherry Liney. Well, it's actually French. It's Cherry Liney. Cherry. Yes. Oui, oui. Très bien. All right. I want you all to notice something. The two previous equations that we used both looked similar, didn't they? What we used was f of x equaled 2x plus 3, wasn't it? And the second one was g of x equaled 1/2 x minus 2, correct? Look at those. Do they look similar? Somewhat. There's an output, right? There's an x, right? There's a coefficient. There's an x, there's a coefficient. Then there's a constant, then there's a constant. Does everybody agree? Okay, now look. Do those look like that?
Yeah.
Y is an output. F of x is an output, correct? M multiplies by x. Does 2 multiply by x? Does 1/2 multiply by x? So is that the same? Then we added a constant. I added a constant and then I subtracted a constant. But subtraction is just adding a negative, isn't it? So this is the same as this, correct? This is what is called slope-intercept form. Now, I want you guys to look at the two things we graphed. Right? What was the slope of this one? We went up how far? How many squares? 6 squares, right? But we went up 3 in value, correct? So we can say it's 6 because it was 6 squares, because each square equaled a half, right? So since they both equaled the same thing, 1 square up is the same as 1 square to the right, yeah? So we went up 6 and over 3, right? What direction is up on a graph, positive or negative? Positive. What direction is right on a graph? Positive. So I went up 6 and I went right 3, correct? In our last unit, distance and time gave us speed, didn't it? When we went up 1 kilometer and right 1 hour, we were moving at 1 kilometer per hour, correct? Okay, I've gone up 6 and that way 3 kilometers per hour. Kilometers were the dependent variable, right? What's my dependent variable here? 6, yes? And my independent variable is 3, isn't it? So this would be 6 divided by 3, correct? What is 6 divided by 3? 2. What do you notice right there? Look at this one. I went up how far? 2. I went that way how far? 4. 2 divided by 4 is 1/2, isn't it? What's that? Does everyone see? Which means if it happens twice, how often does it happen? Always. The M always gives what we call the rate of change, because that's what we called it last unit, correct? If we're talking about distance and time, then it gives us a rate of change. It gave us the speed. If we're not talking about distance and time, we're just talking about x's and y's, it always gives the slope. And that, for some of you, will be a new word. Okay? The slope is the rate of change if you're comparing two things. We're not comparing two things, are we? We're just comparing x's and y's. Does everybody understand? Slope is the change in dv divided by the change in IV between 2 points. Now, if we're doing distance and time, it's IV dV, right? But here we're using x's and y's. So it's also the change in, I'm going to use this triangle symbol because that means change. Change in y over change in x between any 2 points. And I'm going to show you what I mean right now. Is everybody cool with slope for the moment? Yeah. Yep. We're going to do this in like 1 second, okay? I want to show you something else. We already know what x's are, right? We already know what y's are, right? We know what m is now, right? So the only thing we got to talk about is b. We've talked about slope, so b must be an intercept, right? How many intercepts does a line have? It has to have at least one, right? If it's a diagonal line, it's got 2, correct? Watch. What was that intercept? That was -3/2, correct? What was that intercept? 3. What do you got there? 3. That intercept was 4. What was that intercept? What kind of 2? What do you got right there? -2. What did you have right there? +3. So what then is b? It is always the y-intercept. Because x becomes 0 at the y-intercept. Is everybody cool with that? All right. We got to make sure of 2 things now. Everybody put a letter A there and a letter B there. Everybody cool? Now, draw the cross through there for the x's and the y's. Everybody good? Okay. If I want to travel from A to B and I want to find the slope, I need to check which first, my y's or my x's. What goes on the top? Y's. So I would go up here. Do you know how far up I went? No. But up is what in math? Positive. So I went in a positive direction, didn't I? Then I went that way to the B. What did I get? Is that a positive or negative direction? Positive. So this slope is a positive change divided by a positive change. Does everyone agree? So this would be a positive slope. Y'all good? What if I reverse my direction when I get there? And I go down here. What's that? Negative. And then I go left. What's that? Negative. So down here, it's negative divided by a negative. 2 signs the same. What's the answer? Positive. So this is always a positive slope. Do you understand? Great. What is happening here when I go from C to D? Why would it be negative, Kevin? No, it's negative. You were right. But why? How do I get from C to D? I would go down, which is what? Negative. And then I would go right, which is what? Positive. So this would be a negative divided by a positive change. Understand? What if I went on the other side? What's this? And then what's left? So over here would be positive divided by a negative, which would still be negative. Is everybody good? What's weird about this one? It's straight up and down, isn't it? So if I go straight up and down to go from E to F, what's the up part? Positive, correct? Did I move it all sideways? So that would be dividing by 0, wouldn't it? Are we allowed to divide by 0? No. So this is what we call undefined. I like to remember it as infinite slope. What activity do we always use the word slope for? What physical activity that many of us do, but not all? Going where? Going down slides. Perfect. Absolutely right. Another one would be, I heard someone say skateboarding. Another one, skiing. Snowboarding, right? We use the word slope all the time, don't we? If this were a slide, could you slide down it? No. You drop. It's not a slope. You do not want to go down this slide. It will hurt. Hey, Miss.
Have you ever been to Coldest Lake? Have you ever done the big slide, the big drop? The waterfall where you get the wedgie from hell?
Yes.
That hurts. I did it once, and it took like 2 weeks to get my underwear out. It was gross. And then
Wear a
you're not
Speedo,
allowed-
Mr. Shippets.
Thank you. And you're not allowed, when they tell you, that freaked me right out. When you get on the slide, they tell you to cross your legs.
Don't
Because
forget to cross your legs if
You
you're
got to
scared.
cross your legs because otherwise you'll be ripped wide open. That's
Mr. Shippets. I actually don't, I don't like the caterpillar slide. I go too fast. I go off the slide. I go ba-boom, ba-boom, ba-boom. I go very, very fast. All right. And finally, G to H. G to H. Do I go up and down at all?
No.
So it's 0 divided by a positive, correct?
Yeah.
What happens when you divide 0 by anything? You get 0, don't you? So no, it's not undefined because you can divide 0 by stuff. I have no pizza. Do you want half? Here you go. How much pizza do you have? None. You with me? This is what we call a 0 slope. Why? Would that be a very fun slide? Here I am. Everybody understand? No slope, because it's flat. You can't slide down it. Infinity slope, because you can't slide down it because you're going to fall. Is everybody good? All right, now, notice I've got this little box down here. Slope is an incredibly important concept. You have already seen that a rate of change on a graph can tell us the speed, right? Without ever knowing the speed, if you have 2 points on a distant time graph, you know how fast you were going, yeah? Slope is very useful. Because it's so useful, there's a lot of ways to find it. I'm going to write them all here. You know a couple of them already. First, if you ever see this, if you ever see, this is the first way to find slope. Y equals something mx plus b. M is your slope, always, no matter what. What if it's not y and x? What if it was distance equals m times time plus b? Is your slope still that? Yes. Okay? Always. That's the first way to find it. Number 2, you do rise divided by run. Rise is what direction on a graph? up or down, right? Depending. Up and down divided by left and right. Just like we did here. Up, positive, divided by right, positive. Everybody good? It's also the change in the dV divided by the change in the IV. How far did we change on the y value divided by how far we change on the x value? Everybody with me? And the fourth thing it is, and this is the one that's going to be very useful to you in the future, what math tells us a difference between two things? Subtraction. What do we measure x or y on the dV? Is that x or y? Y. So if I need a difference in dVs, it must be y minus y, correct? Because that's difference. But what is y minus y? It's 0, isn't it? So I can't write y minus y. So what we write is this. y2 minus y1. So if you have two y values and you subtract them, you get the change in y. So what then obviously goes on the bottom? x2 minus x1. Is everybody cool? Now, where could I find x and y values to put in here? Where do x and y values live? Where do x and y values live? On a graph, don't they? Everybody with me? Let's make sure. On this page, you are going to use these four, and I'm going to use four different colors. You guys are probably not carrying four different colors. That's fine. Slope-intercept form, put these on this graph. I'm going to do the first one with you, which I'm going to do in red. Slope-intercept form, remember, is y equals mx plus b. The slope is m, the y-intercept is b. Which one of those gives me a starting point? The m or the b? The b gives me a starting point. So, in this first function, what is my starting point? Negative 4. Why is it negative 4? Because the b is negative 4. That's b. 1, 2, 3, 4. Does everybody understand that? Because I can't go on if you don't. Does everybody get that this number is my y-intercept? Is everybody cool? Great. What is the m? That's my slope. Right? Slope is rise over run, correct? Okay. But that's a single number. How can it be a rise and a run? What is this really? What is 2 really? 2 over 1, isn't it? So what's my rise of 2 from here? How do I do that? How do I rise 2? I go up 1, 2. How do I have a run of positive 1, right or left? Right, 1. Now, Mr. Myers says you always need 3 points. So I'm going to go back to here. Can I go down 2 and left 1? Negative, negative. That gives me a positive, correct? And there's my line. How far will that line go? Forever. So could I go up 2 and over again? Up 2 and over again. Up 2 and over again. And that gave me an x-intercept and a y-intercept. Is everybody good? Now, with your neighbor, or by yourself if you get it, try to do B, C, and D. Go. Everybody tried at least one now? If you haven't tried one, you must be honest with yourself. Are you not trying it because you are lazy, or are you not trying it because you genuinely do not know what to do? Michael, you just put your hand up. What? You've tried some? Okay. Let's do B. What is my starting point? Michael, I'll let you do this one because you're ready to go. +1, which is right there. Does everyone agree? Does everybody understand why I have a dot at 1 on the y-axis? Yes? Okay. What's the slope, Michael? 1/1, negative, right? So I got to go, I need a negative rise. Would that be up or down? Down covers my negative rise. And then do I go right or left? Right, because I need it to be negative. Down 1, right 1. Now, once that happens once, how often does it happen? Infinite. So I can go up 1, left 1, up 1, left 1, down 1, right 1, down 1, right 1, forever. And there is that line. Is everybody good? All right. C looks harder because you're all scared of fractions, aren't you? Okay. But in this case, it actually makes it easier. Because what's your starting point? 5. Positive or negative 5, Evan? Positive 5. 1, 2, 3, 4, 5. There it is. This is my slope, correct? Slope is rise over run, isn't it? So that is 1/3 negative. Doesn't that mean that's rise over run? So how do I do a negative rise from there? I go down 1. How do I do a positive run? Positive? Right. 1, 2, 3. And how long will that continue? Forever. So I go down 1 and over 3. Down 1 and over 3. And what do I get? This line. Is everybody good? Now, D is very tricky. There is no number out here for B, is there? What number is nothing?
0.
So what is my y-intercept? 0. There's no number in front of x. What is the number we don't write for multiplying? 1. Is that a positive 1 in front of x? It would be. So I would go up 1 and right or left to keep it positive. Right. What if I went down 1? Then I'd go left. And there is that line. For how long? Infinity. Does everybody get it? Now, because this always happens here, just to remind you about last unit, I asked you to do this. Which of these lines, green, blue, black, or red, is A? Why? How do you know the red line is A?
Because for F, it would be Fx, and since 2 is the x-intercept for the red one, that would make sense.
F of x, F. So this must be the red line, correct? Now, is this an x or a y value? It's an x value. So I would go to 2 on the x-axis and see where the red line hits it. Where does it hit? 0. So the f of 2 equals 0. Everybody remembers that, right? You're about to be tested on it. What color line is B? Is it it's the black line. Is that an x value or a y value? X value. So I go out to 1, 2, 3 right there. And now I need the y value. It's right there. What is it? 4. Everybody good? Is this an X or a Y value? It's a Y value. On which colored line? Blue or green now, because I've done black and red. Blue. So I need to go to the Y value of 4. 1, 2, 3, 4. And now I need to find the blue line. It's right there, right? What's the X value of that point? Negative what? -3. Except I want my blue line back. And I need the value of x when the f of x is -1. Which color is f of x? Red. So I need -1. Is that a y value or an x value? That's a y value. So I go to -1 and I find the red line. Right there, correct? We did, but I'm doing it again. Because I don't want to bother using the green one. Because this gets me what as an x value? It's halfway between 1 and 2. So what is it? 1.5. Can everybody do this? Does everybody see how this actually helps us with our last unit? All right. You have 18 minutes left in class, 17 minutes left in class. I'm going to give you the choice to work on either your review from the last unit. If you didn't finish it, yesterday we went over it all, but maybe you didn't finish it. You can look it over. You can start this, which will also help you for your test, 384 and 362, which for you guys is page 182 and 183. These will help you for your test on Tuesday. You can work on them if you want. I also have a couple of copies left of that extra review if you want to work on that. It's totally up to you. Okay? But every one of you have something you could be doing for math right now. When is your test now? Tuesday. Second block, so it's not first block after a weekend. Okay? And this will be put up on YouTube as a key today. Okay? The one I gave out. Yep.